Hey guys, what's up? Tim Queen here, and today we're going to create some LinkedIn content, and it's going to be about cybersecurity. I'm going to create some content for myself, and I'm going to take you along. You can look over my shoulder, and you can listen to my thought process as I'm creating the content, so you can get an idea how you could apply the same logic and the same thought process and the same steps to your own niche. You don't want to start creating broad content that is like really high level in your industry. You want to go down really, really deep. Like you want to find some like 5, 6, 7 layers down in terms of your content map. We're not going to try to become like a thought leader in like a broad field, like in my case, cybersecurity. We're going to try to become a thought leader or like a micro thought leader in a specific subtopic. And what I've picked today is going to be like one of those subtopics deep down in the content graph, and it's going to be about passwords. Now, in order for this to make more sense, let me actually pull up like a graph so it's all easier to understand. So the little mind map here, I'm going to actually like just put this as an overlay so you can actually read it along. Before we get started, I want to talk about like, well, who's the audience of the content? In my case, I'm trying to establish myself as the thought leader in that field. That means I'm looking for management, looking people in GRC, we're looking people in the cybersecurity field, and we're looking at general audience who is generally interested in security. There is, of course, different levels of the audience, like all the different groups are like very different characteristics. But what I'm trying to do is like, I'm trying to understand like, what are some of the topics where a lot of people have misunderstanding, and like my focus will be like on the people who know the least. Like we don't have to convince the person working in cybersecurity about like the value of passwords they already know. But some people working in GRC might not, but they might now have some sensibilities like for security, but they might not be aware of the nitty-gritty details. And like of course like the general audience, they might know the least. So we're trying to find some ways, A, finding topics that we can talk about so they can learn something, and then B, we want to present the topic in a way that actually makes sense for the different audience groups. Let's start actually with our password list. And like the first topic I've selected is kind of like, I want to talk about like the purpose of passwords. Like what is a password good for? Because a lot of people just seem to see it as an inconvenience that they have to like memorize, but I don't really like see the point. Like who's going to go to my desk and like access my files like at work? People don't really see the danger that they are facing. So that's why a lot of times like people just choose very insecure passwords. So one of the topics how I could establish myself here in the field is actually like making people aware of the different reasons why you actually need a secure password. How does like helping protect you, not just like at your workplace, but like also like personal life. That might include talking about some of the dangers that come when someone might be able to guess your password and then like abuse your password and like impersonate you or like scam you or like any other type of abuse that could happen from someone knowing your password. So that would be like a good starting point, talking about the values of password, like what is a password good for. I want to talk about password leaks. I think this is another good starting topic that a lot of people can relate to. Very few people know actually how many times their password has already been leaked online, like how many data breaches their information has been shared. And it's not just about passwords, it's primarily about like their personal information, like their name, email addresses, like maybe their birthday, like where they live, like which company they work for. And there is a couple of different websites where people can actually do some research about finding out if they actually have been hacked and like even like setting themselves up some email alerts. So that could be like an interesting topic to just get people like more aware and more interested in the field of passwords. Because what I'm trying to do is like, I'm trying to get people interested in something that most people perceive as like no value or like very boring. So I have to start with some like general topics first that are like really relatable to a lot of people. Then we have password recommendations. It's all about like the different myths around passwords, like what are some of the things people believe a password should be. Should be very complex. Should it like change your password like every 2 weeks? We're going to talk about some of the math, how password security is rather unintuitive in terms of when it comes to safety. Like what people believe is secure is actually like not very secure, and what people believe is very insecure is actually very secure. So that's going to be really interesting. There are going to be a lot of aha moments that we're going to talk about. We're going to talk about recommendations, like what are some of the different regulatory bodies like recommending in terms of passwords. And then we have a topic, it's going to be a bit more technical. I'm going to talk about password cracking. There is a lot of interesting things how people can crack passwords. It's like when someone hacks the company, that downloads the database, and then like there's different forms of security, how the password might be encrypted, the different methods that companies can actually use in their development when it comes to securing their software. There's software as a service, web applications, store them so securely that even if they get hacked, like the data is basically like meaningless. There is a lot of interesting algorithms, and that might actually just something really interesting like for some people working in DevOps that might not be that security aware, but like just giving them some keywords that they can like work on. Like there's a lot of cool technical implementations to implement some of those methods that I'm recommend. We're gonna have some topics about like other means, like how people can get passwords. We're gonna talk about the $5 hammer method and how to protect yourself against that one. We're gonna talk about password managers. Like this is really like a topic that very few people know a lot about. Like some people are scared. They might like, if I have like all of my passwords in password manager, is that not more dangerous? And if someone guesses my master password, then I get access to all of my passwords, which is very unintuitive, but it's actually like way more safe than actually remembering it. We're going to talk about how to select a strong master password. This will be like the same as we talked about selecting a secure password earlier. We're going to talk about password entropy versus complexity. That would be a little bit more technical about the math of passwords. Then we have a few more things about the backend and passwords. Like it's not just about how passwords can be encrypted, but it's also about like the different hashing algorithms and the different techniques that can be used to make a password more difficult to crack. Different forms of encryption, how to secure your web server. We're going to have some topics about password security flaws, password reset mechanisms, another topic like more for the development side of the passwords. And then we're going to have some interesting conclusion when we actually come to how can we like make this like really almost impossible to crack when we talk about multi-factor authentication, like the different methods. What I've created here is kind of like a map. And every time I wrote on each of the point, I was thinking about the different audience groups that are eventually like supposed to read the content. So the thought process is this, like as I explained earlier, you want to have an audience and you want to start with something more generic generally. Like think about this, you're warming up your audience. Like if you're like a football player, you don't just like start running onto the field, you're warming yourself up, you're running some rounds, like you're kicking some balls. This is the same thing on LinkedIn when you're creating content. You have to warm up your audience. That means you have to make it relatable to the average user. That means you want to start with like the more interesting aspects of whatever content in your industry you're working on. Like let's say you're like an accountant. You don't want to talk about some special rare case of tax law that is only relevant for other accounts. You want to have something like more general, like how can someone save like $100 in this year's tax return, like with like some simple step that doesn't take more than 5 minutes to do. Something like this is like way more relatable and you're going to get much better engagement, but it also kind of like brings your content in front of the audience that you actually want. So you want the pathway to getting your small narrow audience is to start with something more generic first, then it has broader reach and it will be seen by more people, which also means it will be shown to people like who follow the same hashtags, which are more usually like more the niche people. What's really important is when you're creating the content, you don't want to put too much content into one post. You really think of like atomic content. This is what you want to go for. You want to have content that is really small and bite-sized, just like one thing. Like let's say I want to talk about how to select a good password. I'm not writing an article. I'm not going to talk about the history of passwords. I'm just going to make this article or this post in this case about how to create a strong password. The same as when you're like an accountant. You don't have to talk about how someone can register their business with like the government. You're not going to talk about how to technically submit the tax return form. You're not going to talk about how to fill out every single field in the tax return. You're just going to talk about you have to go to page 13, section 5, and you write this into this field and you put a check mark over here. This will get you your $100 tax savings. It's really important because if you don't do that, you don't have enough content and you don't have enough characters in a post, even if you do video. But it's also like you're not going to get the engagement. You have to start with the value proposition really early on. And then you have to deliver that. You're setting the hook, you're telling them what they're going to expect in this post, and you're going to deliver on exactly what you promised them in that hook. And it has to be done really quickly, because like when people like don't know you, they will not spend the time reading about this. Once they know you, you have more leeway and you can write a bit more complex topics, but at the beginning, you have to warm up your audience first. So you have to be straightforward and have to like get straight to the point. Now what we're going to do is like, it's a little bit windy down here. I'm going to take you along and I'm going to go back to my computer and I'm going to show you how I'm actually going to write this post about passwords. Sounds good? See you soon. Bye. We're back at my computer and we're gonna now create the LinkedIn post. And if you remember correctly, we had a lot of different topics to choose from. And I think as a beginner topic, to get the normal person, the average person, excited about passwords, even though it's very boring for most people, we're gonna actually pick something that's very counterintuitive. We're gonna compare two passwords. And it's like what I'm gonna do today to get people curious. And let me actually just head over here and copy you some information. So we have something to compare with. We are going to compare this password and we're going to compare it with this password. So there's two passwords and we're going to compare whether or not one of them or both of them is going to be a secure password, and we're going to explore why. And you may be already guessing it, but this is not the best password. It's actually like a very insecure password in a lot of ways. And this one is by bounds more safe, more complex, and will be way more difficult to break. There's a couple of different reasons for why this is the case. Let's compare it on a practical level. I'm just going to explain to you like the logic so you have like the same background knowledge as me when we were creating the post. So it's important to understand those differences. So this one has all lower caps. And if you remember, like a lot of times you sign up for a website, there's always like some password requirements where they say like, yeah, you need to have like an uppercase character, you need some special character, you need a number. Here we have substituted the O for a 0. We have small caps. So we have, technically speaking, when we look at like what most password requirements dictate, we have here a much better password. Like this looks more safe, more secure. I would have guessed that we use the @ symbol to replace an A or the $ for an S or the 0 for no. Very clever, right? But you would be wrong. And this, on the other hand, is just like 4 words. It's all lower cap, some spaces in between. Like, doesn't really look that complicated to crack until you actually see the math. So let's actually pull up the math and have a comparison. Now, I'm going to show you 2 screenshots that I've taken from a password meter. Gonna go over here. I'm going to reduce this. I'm going to pull this over, and then we have a comparison. So this one is the password strength meter for the word password. And here's the same one for, let's actually see if I can line them side by side so it's easier for you to see. Now here you can see if we had a massive cracking array, that just means we have like a lot of very high powered computer like working in parallel, maybe like GPU accelerated computers. You could crack this password in like 1.12 minutes. Probably even faster, and I'm going to tell you like why. The reason why is, you see this word password is literally the word password. And even though there are some substitutions like the @ symbol, the $ symbol, and the 0, that's actually a very well-known tactic by people to do this type of word substitute. So there's a limited number of characters that someone might replace an A4 or an S4 or O4. So people know this. Like, for example, you might have the number, you have like an E, people might replace this with like a 3. So because that is known, some people sat down, they actually have created some password cracking mechanisms where they just like test variations of words. And not just like test the word password with everything is like a normal character case, but just replacing one character with an @ symbol, and then one @ and one $ symbol, and one @ one S, one $ symbol. So they can go through all of the permutations of the word passwords and just adds like a few extra variations to the list. And typically most password cracking mechanism on a decently sized computer can literally crack like millions of different password variants per second. That means like if this was actually like on the password list, This might just take like seconds. So, but like if you do a brute force attack with like all the different possible variations, it would just take like 1.12 minutes. Now this, on the other hand, will take several trillion centuries if you wanted to crack this. Now the real is very interesting. So there's different ways to look at it. You could look at like the length of the password, because when someone wants to crack a password, what they have to do is essentially they have to start testing out the letter A, then B, then C. Someone they're going to be ending up at Z. And then afterwards, they have to start over A, B, A, C, A, D, A, Z. And then they're going to go B, A, B, 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 C, B, Z, and we're going to end up, you get the pattern. Like it just takes, and with millions of patterns, you can actually do it really, really quickly for a very short passwords. So, but this becomes exponentially more computational with every additional character you add. So if you could say, and we're assuming that the attacker actually knows exactly how our password is composed, you could say we have 27 characters, 26 A to Z, and then we have one additional for the space characters. So you could say we have 27 characters, and we just take this to the power of the number of characters that we have. This is the number of permutations the system has to go through. Obviously, if we have 1, just 27. If we have a password which is 2 characters long, 729, 3, 19,000. But as I said, they can crack millions of permutations per second. 4, 500,000, so that might take half a second. Now we have like 14 million, 6, and you can see how this becomes really complex really fast. 7, now we have like a billion. 8, actually not a billion, we have 387 million now. We have now 10 billion and so on. But as you can see, our password, let's count the number of 34 characters. Pretty big number if you see 10 to the power of 48. That's somewhere along the lines of what we just had. Here's the big but. Let's actually look at how many characters do we have to compare if we do like a password meter. So just for fun, this is 33 characters long, and this one is 1, 2, 3, 4, 5, 6, 7, 8 characters long. And just to be clear, so we're just gonna like do some math. It's just for fun, so you are in the same mindset. We have 26 characters for A to Z plus 1 for space. It's 27 characters choose from for our sequence. In this one, we're going to say we have A to Z plus A to Z plus 0 to 9 plus, and we're going to say like the most, so roughly 40 special characters that are easily accessible via the keyboard. Of course, there's like more characters, but we have to go with like what the normal person would do. So let's actually write this down. So we have 26 characters for A to Z plus 26 characters for A to Z plus we have 10 characters for 0 to 9 plus 40. And then if we do the math, we have, I'll put up another character, 26 plus 26 plus 10 plus 40 is 102. Now, if we have the math here, remember the formula was over here was 27, the power of the length of the password, and it's going to be difficult to type, to the power of 34, okay? And this one, on the other hand, we have way more. We have 102 to the power of 8. We'll bring this over here. Here's the number that we had, or E just means times 10 to the power of 48. But then let's do the same math over here. We're going to do 102 to the power of 8. And as you can see, there's a pretty big difference between 10 to the power of 16 and 10 to the power of 48. So let's bring back our chart, because this would just be if we just know the character set. If we know this is all small caps and a space, and we know exactly that this one could be all the different special characters. You could also look at it at a different way. You say like, yeah, how many words are there? Maybe I just have to test out all the different combinations of words. So if I have a list of words and have a space character in between, we don't have to test for the space characters. So we would just go and do another way of calculating this. We would say another way of looking at this is like the number of words to the power of 34. to the power of 4 because we have 4 words. So the total number of words to the power of 4. Now, how many words are there? Of course, there's different languages we could look at, but we're just gonna make it very conservative. We're gonna look at, there is a common word list that you could download with like some of the most common and well-known words of the English language. So there are lists very common, like there's a word of 3,000 of the most common words, and there's also like list with 10,000 of the most common words. And of course, if you expand this to like all the words, you probably end up like at having maximum like 100,000 words or more, depending on if you like include like scientific terms in different industries. If you expand this to the number of words like in all the different languages, this number will quickly rise over 1 million. So for fun, for this word that I actually created, I'm going to take the 10,000 most common words and we're going to do this to the power of 4. So this gives us the number of choices is 1 to the power of 16. So for fun, we're just going to do that again, better to actually visualize this. So here we have 102 to the power of 8. And then we have this number, 17 digits. We're going to go for this number. We just go on and copy this over. So it's like more visually appealing if we write it down like this. Then we have 27 to the power of 34. It's a very large number of combinations. And then we have 10,000 of the most common words to the power of 4. And then we have this number. Now, if you put them side by side, it actually turns out if you look at it like this way, this would be slightly more secure. The point that's really important to make here is that we assuming that someone knows exactly how your password is composed of. Because when you're looking at, like, if you know this information, you might apply this 10,000 most common words and start just permutating the words. But let's say you don't know, did I put a space between each character? Or did I just merge them together into one stream? Or did I actually substitute one of the characters? Or am I just like a normal person and I would never pick 4 words? I would just pick something like short, like maybe 8 to 10 characters long. So from the perspective of the attacker has no knowledge about how your password has been composed. So they have to assume that most passwords are actually like short. So it makes much more sense for an attacker to actually go brute force method and actually trying to crack the password by testing all 102 characters in a row, at least like as a second step, because I'm going to show you later, most attackers don't even bother going brute force because it's much easier to crack them with a dictionary. So if the attacker doesn't know this, they actually have to start cracking this way. And if they then go and have to try out all 34 combinations, then we're going to see 102 to the power of 34, that we're ending up with this number. So this is when an attacker doesn't know what we have. They might have to do this many guesses because they have no idea how a password is composed of. Here's the interesting bit. We can actually take advantage of this system and combine both of them. And the trick is that we're actually going to use like really randomly generated passwords. Let me actually show you one. I'm going to use this one from 1Password. And we're going to really choose like something like crazy. How about this one? How about this? This is like 100 characters long. And one thing you have to keep in mind, you will probably not be able to use that in every platform because some platforms, for some reason, artificially limit the length of their password field. But it doesn't matter. Like you just like dial it down to like whatever is like the maximum number of characters. Even like something like this, 30 characters. It's still absolutely crazy. So I say we have this password 100 characters long. We copy this. So if I go and I have this password and I have like this unique email address, like unique email address at gmail.com. This is like my special character and this is like this password. And let's say on another website, you have the same email address, might even play some fun games over here. What I say, I'm generating a new password. This is a new one. It took me like half a second. And I have another one. Now we have the amazing math for each individual website that I have 102 characters to the power of 100. Now, if an attacker wanted to steal this, let's copy this over for fun. The strength of this password would require this many guesses because now the attacker, even if they know that we use the entire palette of all special characters, small caps, low caps, numbers, whatever you can think of, it will take this many approaches. So what my strategy would be to select a memorable password. This is something like this that can actually only be entered on your local computer. So you don't get perfect security, but again, the attacker doesn't know it. And if you wanted to, you could still add characters somewhere. In some of the words, maybe you're doing the trick with an O, replacing with a 0. The attacker doesn't know. Even if they knew that you had those, if you had the list, you picked your random words from a list of 10,000 combinations, it will still take them this many attempts to crack the password. And even if they can crack 1 million passwords per second, let's just do that for fun. Even if they can do that, I'm going to go over here. We're going to divide this by 1, 2, 3, 4, 5, 6. Let's just double check 1 million. And then we have this number of seconds. So we're going to divide this by 60 seconds. This will give us the number of minutes. We divide it by 60 minutes, which gives us the number of hours. And we're going to divide this by the number of 24, which gives us the number of days. And even in that scenario, let's just break it down a few more times by the number of years. And then it will still take 317 years of cracking just one password. Even if the attacker knows and he didn't do anything special, even cracking a password with 4 choices will take them 300 years. And realistically speaking, it is not going to happen. It's just like you're not that big of a target that someone would bother spending 317 years of compute power by the time you already died 3 times. There's no point. It's not realistic. We'll just waste a lot of time. It's just easier to build everything up from scratch in 317 years. Let's just look at what we achieved in the last 100 years in terms of technological progress. So it's just not worth it, whatever is hidden with your password to put in that amount of work in. So now that we know all of this, now let's think about how we can actually turn this interestingly into a post. The way I want to lead this, we need a hook. Somewhere we have to fold. That means we have to get someone's attention in the first few lines of text. So we're going to use a curiosity hook. We're going to see how we could phrase it. We're going to compare this. And of course, for the hook, we can be a little bit more free. We don't have to explain the entire math. We can do that later. We can have a bit more freedom in terms of how we present this information. What I'm trying to do is I'm trying to imagine in my head how this would sound. How does it would sound when someone is reading this? So I think, how about this? It takes 1 second to break this password. And I'm going to explain the math, how I'm going to portray it later down in the post. And we can we just said 1.12 minutes, but there's another way, what I just mentioned was a word list. It actually requires, this is a lot faster. And then we're going to compare this, and we'll say, and now we're going to be a little bit tricky. We're going to add a couple of line breaks. So people actually have to they have to click on the next page, or they have to click the read more button in order to read this. So we're just going to say it takes maybe even make it crazier. 0.001 seconds to break this password. And we could, sometimes it's difficult to read, so we might have to think about how we can present this in terms of emojis. We're going to put this, so what we could do is try to create some kind of visual cue that there is something worth looking at. I'll give you an example. Let's say I pick this, so it's a little bit easier for the eye to look at. So, and then could do the opposite. Let's say I copy this, I put this at the other side. And I say it only takes to crack this password. But this password, we're going to pick this. You could do something like this, but we don't want to overdo it. And I feel this sentence is not 100% it doesn't flow yet. It only takes 0.0001 seconds to break this password. But this one, so we're going to leave that. We're going to leave a couple of extra lines. I'm going to come back to this later. I just have to have some thoughts about this. And it's really how you want to think about this. When you start writing a post, don't get hung up too much, because I could spend a lot of time thinking about how to write this. I'm just going to get the structure out. So I'm going to say, what's the super secure password. It's this. And again, with the formatting, we can do that later. We just want to get something out. I'm going to play like a little game. I'm going to pretend that I'm the audience asking me a question. I'm actually like having like a conversation with the reader. What? How? And I'm going to answer this. So I'm using this kind of conversational style to make this a little bit more accessible. How? Well, even a normal PC can crack 1 billion passwords per second. Well, even a normal PC can crack up to 1 billion passwords a second. So let's say someone wanted to try out every password, every possible password. Here's how long it would take. Assuming we have 102 possible characters. Assuming that we have 102 possible characters, and we can test 1 billion combinations per second would only take, and then break a password that is 8 characters long. We're actually going to do a little bit like, I'm going to look up this number. I have to check out like what, we're going to use like some beefy machine, like some benchmark, and assuming like a GPU, because I want to make this as accurate as possible. But for now, I'm just going to like show you a structure. So we're going to actually calculate how long it's going to take to crack an 8 character long password, excluding all the special characters. So let's say this one, we're going to say like 1.4 trillion password guesses per second. And let's have a look at what kind of machine we have here. A cluster of which we run our password cracking engine consists of 4 unit server, include both Xeon EPYC processors, 8 NVIDIA 1080 Ti GPUs. I mean, there's honestly something like if someone wants to crack passwords on a regular basis, might actually have available. So we have 1.4 trillion password guesses per second. So we just have to go back to our math and we have to replace this. And then we should get a different number. I actually forgot I should have divided this by 24. So here we have 2.32 hours. Just let me verify this. We have this number of combination, this is the number of tests per second, the number of seconds, and the number of minutes. This is 2.3 hours. Take us 2.3 hours to break a password that is long. So now that we have the math, now I'm gonna like play back the card. So now you're saying would take 2.3 hours. How does this work with 0.2 you mentioned earlier? Don't worry about the structure like the grammar. I'm going to forget about this. This is just like this. We're just going to build up the structure so we can later write this in the next iteration, like smooth out the sentences. There is a trick. People are predictable, very predictable. Most people use the same password. In fact, about 20% people use the word password as their 1, 2, 3, 4, 5, 6 as their password, closely followed by the short password in second place. Okay, most attackers will try the most common passwords. First, I see you. Didn't think anyone would find out, would you? Now we're going to put this little like joke inside here. And then some of them will try the most common passwords first. There are lists the most common passwords in the world that you can download in seconds. So the app, most password cracking apps will try out all entries from this dictionary first. 1, 2, 3, 4, 5, 6. Password, QWERTY, I don't know, love, etc. But people gotten smarter. They are now adding characters to their password. So now it might be as safe and secure as password 1 or password or even password. You see, this is called a hybrid dictionary attack. It uses the most common passwords and tries out all possible permutations by substituting A for @ S for $, E for 3, etc. There is a limited number of common permutations that most people would use. And since we can crack 1.4 trillion passwords per second, it doesn't add much extra time to try them all. Okay, so that's why a password such as less than a second password with such as, where we have the password that contains 4 randomly chosen words from list of the 10,000 most common words is significantly more difficult to break. The attacker doesn't know how you selected your password. Most people use dictionary terms with or without variations or additions or common patterns such as birthdays, etc. Most passwords are also very short, maybe like 6 to 10 characters long. So it's much more logical attacker to brute force like all combinations for shorter password, which with 102 characters and 34 characters long require this many attempts. That's time for another. We have to see if we actually have enough characters. 1.8 to the power of 34. We're saying as many attempts. Oops. So even with 1.4 trillion guesses per second, it would still take, well, we're not going to get hung up on this. We're just going to take the number that we had previously calculated, which was, where is it? 2 passwords. In this range of characters, it doesn't really matter that much. So we're going to just take this and we're going to say at about. Even if it's costs a trillion years more, who cares? We'll still take about trillion centuries. I want to have another rebuttal, but Tim, what if they knew that you picked dictionary words? Well, let's do the math of this too. 10,000 to the power of 4. Actually, we're not going to make it this complex because then we have to explain the countermeasures that we would take in order to actually bring this number down. I think it's time for us to do a little bit of cleanup and then actually try to reread this entire post again. So it really takes this many seconds to break this password. And this one will take 63.41 million times centuries to crack. Sometimes you will realize that actually a topic, you just want to make it kind of black and white. You don't want to have all the different nuances inside, because then otherwise you have to explain a lot of the details and the post gets too long and it kind of loses a lot of its clarity. So let's see if we can simplify this by changing the structure a little bit. And then you see we're talking about later about 1.4 trillion passwords, but then we're going to use the word normal PC here. So we're just going to simplify this. We're going to say a PC that has been optimized for password cracking can guess about 1.4 trillion passwords per second. And then we're gonna not write all of this with 102 possible. Then we're gonna see if we can actually shorten this to A to Z, 0 to 9. Yeah, we're gonna make it simple like this. Let's do the math. We have 102 possible characters. The password, and actually we're going to copy this so it's kind of easier to read from people is 8 characters long. So if we try all combinations, we have 2 nations. Number of all possible combinations is, and then we're just going to go back, 102 to the power of 8. You see, sometimes like a post like this, it takes some time to develop. So we have this number, and then as we're like getting along, we have to kind of divide this now, divide by 1.4 trillion, divided by 60 seconds to get the number of minutes, divided by 60 minutes to get the number of hours. So we have 2.32 hours. See if Wolf from Alpha can actually do the math. 2.3 hours, 2 hours, 19 minutes, and 29 seconds. So we could say 2 hours and 19 minutes. Roughly take 2 hours, 19 minutes. So we're going to rewrite this. Testing the total, testing all possible combinations. We'll cut this out. Combinations would take 2 hours, 40 minutes. And let's just put like it would just only take 2 hours and 19 minutes. But we are not going to do that. There is a faster method. How about we check the dictionary, the most common passwords? We can actually do that. Let's have a look. So one really cool website is called Have I Been Pawned? And now we're going to actually take this password and we're going to paste it into Have I Been Pawned. I'm going to see if this password is actually used. So I'm going to paste this here. And then we see that there are 34,160 user accounts that have been leaked online because someone hacked into a database that contained exactly that password. The moment something is in Have I Been Pawned, it's on a password list that people will test. Just to make it clear, this was like the one. Now I'm going to add some random stuff here just so you see if I copy this inside and we're checking, it will tell me this password is not existing in any password list. But the other one was, and just for fun, let me actually see if I can turn this off so you can actually read along as I'm typing. We have, where is it? Here, if we turn this off, we should be able to read it. So if we actually put in like the most common password inside, you can actually see that this one has there is 42 million user accounts who have used that. And then if we have passwords, we have 10.3 million people who have used that password. So it's super insecure. So, and then just to highlight, this was the one that we had for Have I Been Pawned. So this one was the one 34,168 times. And then if you can see even variations like this, or some person has tried it. You see the number is greater than 1. Is 1 or greater, then it's on the list and people will test out this list. So this is 1-to-1 on the password cracking list. You can download this and you can just try it out. So it would just take let's actually look, what is the most common password list? Where is it? So of course, everything is bookmarked. So the list that we're looking for is the list called RockU. It's a gigantic text file that you can download. In total, we have 82 billion unique entries. And as we just figured out, it will take us 1.4, we can do 1.4 trillion guesses per second. We can test the entire file of 82 billion unique passwords that have been leaked over the years in less than a second. So this password would literally be cracked in less than a second. There is a fast method. How about we check the dictionary of the most common passwords? And what do you know? Password. Now we're going to combine this with what we just figured out on Have I Been Pawned. Password is a well-known password with over user accounts. Now I could go over the math and explain okay, we have they have RockU 2024 years with 82 billion entries. Let's see if that could be interesting. How about we check out the dictionary RockU 2021 and contains over 82 billion unique entries. Now we could do the math. Let's actually do the math. It's always fun to have some numbers. Don't want to overdo it. 82 billion divided by 1.4 trillion. It will take us about 0.05, meaning, we can try out all 82 billion passwords in just 0.05 seconds. And what do you know? Thought they were so creative and unique. And we have to work on the sentences, not really flowing yet. So let's see, what else do we have? I think this is way too complicated, what I'm writing here. So we're going to cut this out, everything out. It's way too much math, and I don't really think it gets the point across. How about we just explain people how they can actually securely find one of those passwords? I mean, there's different methods. You could write your own application, which would definitely be the safest variant, or you could use one of the more common words methods. One of them is actually inspired by exactly this XKCD comic about the security of passwords, which is actually talking about the value of how much entropy are we actually generating with a password. So this one actually has a built-in password generator. So it uses different words, but maybe you don't trust this. So there's also different other methods that you could use. Give you an example. Where is it? So one of the most respected websites would probably say on the internet is the EFF, the Electronic Frontier Foundation. So they have a list of dice words. So let's take this. Okay, so they have 7,776 words. So this is the long word list. We also have shorter list, and they have unique 3-character prefixes. So they have different word lists. Say this one, how long is this one? This one is 1,296 characters. But each one is it's more unique. So it's it might be easier for you to pick a word which is from a smaller word list, because it might be easier to remember. Some of the dictionary words are fairly complex or unusual. So it might be might be a better idea to start with something simple like this. So let me actually show you how you would do this. So in this case, if you want to have 4 words, you would get 4 dices, literally dices. You can go on Amazon and you buy a dice. Or if you trust the internet, you could go on random.org, and they actually have a random number generator which you could use, which uses some atmospheric noise for true random number. They have literally an antenna somewhere in the building which is picking up random radio wave signals from the atmosphere to generate random numbers, because it's actually quite difficult to get true randomness. So you go here, random integer generator. And then you say you want to have random values between 1 and 6, and then you could generate numbers. And that would also give you an option. So what you would do, let's say something like this, you either do it manually with dices, physical dices in your room, which would be the safest way, or you use something like random.org. And then you go to this word list, and you're going to search for that number. I guess I should have removed 1 digit. So in this case, let's say you're looking for 4-digit numbers. So generating 4 different numbers, you would have Jackrabbit. And then you would do another random test. Maybe let's take those over here. And then you would find the next number, remove the tabs. So here we have sword, Jackrabbit sword. And then we do another random test. And this time we're going to pick this. And let's do one more. Pick this one. And there we have the method. Now you have a password which you have randomly generated. And it's more complicated doing it manually. You can probably trust this one. You just generate a couple of different passwords, or you do it manually. Pick one of the word lists. You can search for it as more complex word lists. You could also open this in your text editor. Generate a random number between 1 and 10,000, and then go to that raw number, depending on your text editor, or use something from EFF. And then you can generate 4 random words. You might have to do a little bit of memory exercise in order to remember this. So it might be a good idea to create a story. You could say Jackrabbit had a sword which he used to slay mammals and barracudas. Or you could go the other way around. You say barracuda is not a mammal. Yeah, you get it. You have to kind of like be creative. And if you like really like don't find something, you can regenerate like a password until you get like one which you can generate like a story. So that's kind of what we want to communicate. So as you can see, there's a lot of different ways how we could do that. And we don't want to overly complicate this entire process for the audience. So we have to think about how we can actually like make this. So I might recommend a method which is the most accessible for most people. So why don't we just test this password and the have I been pawned and see if it's actually like inside. Just it would be stupid to have like an example and then it turns out perfect. On the other hand, it is unique. So how can you generate a safe 4-word password for yourself? This would be like a good time to share some resources. You could use physical dice and a word list from EFF and for unique words one by one. Or if you are looking for more convenience, is it that click on the, what is the button called? Roll dice button. Okay, so I think this is kind of like, that's like a useful outline. So let's have a look if we can actually read this. We actually have to keep an eye out. We have 230 words, so that should be plenty of space to make this pose work. I think now we have the structure ready. There's, of course, a couple of resources, additional resources I could share. Let's have a look. What do we have? If you want to give some credibility, I would actually add like a references section over here just to open this up. There's actually very interesting publications where we can look up at pass phrase. So this is basically the National Institute for Standard and Technology's latest recommendation regarding passwords, which is clearly highlighting that it's better to have something that's more memorable than having some complicated passwords, which then lose their security because people tend to write them down and pin them to next to their computer and stuff. So they're explicitly recommending to have at least 64 characters in length to support like pass phrases like 3 or 4 words. And then we have like the opposite end of the Atlantic. We have the NCSC, the National Cybersecurity Center, which is recommending a 3-word rule. Of course, we're more ambitious. I'm going to say we need 4 words for extra security, but even like a 3-word is definitely better than what most people choose as a password. There is a lot of good reasoning because we don't really want people to fall back and pin the password next to their computer and won't pick something too predictable. So, but I think generally we have the structure right now. It's just time for us to work on the flow, and I'm just going to create like a new version. So it only takes 0.001 seconds to break this password. So I feel like this one I'm going to do last because I really want to like nail the transition. So there's like a certain, I just don't know what it is going to be, but there will be like a really nice flow that then will force people that they want to see more, and they have to click like the next button to read actually the answer. So we purposefully want to have them hanging here so they can kind of think like, if that takes this many seconds, this unintuitive password will take this much longer. So they want to kind of see what it is, and I want to have the explanation of how this works. So what's the super secure password? It's boundary code communication defeat. So I'm going to say, before I explain why this is so much more secure, let's talk about cracking passwords first. High-end PC. So transition-wise, we always have to kind of like look at the flow. Before I explain why this is so much more secure than the first one, let's talk about, and then you see like, we have the sentence, which could be a transitionary sentence, and we have like this sentence, which is another transitionary sentence. So we kind of want to like kind of try to merge this. Let's talk about the math of password cracking first. I see now it's like way better flow of password cracking first. A high-end PC, it kind of like, I mean, it's an important fact, but it's not necessarily like needed to tell the story. Can guess. So we're gonna really make this like simple because it's easier to understand for people. They don't necessarily need to know how many GPUs to be put in. Was it like NVIDIA graphic card? Did we use like Intel processors or AMD? Like they don't really need to know this. They just need to know that it's possible to buy this. And I mean, not for the average person, but we're talking about people like who want to crack passwords. They might even be able to buy 100 of those and leave them in parallel to crack even more passwords. 1.4 trillion passwords per second. And now because we're talking about math, we kind of have to like think out loud in our posts. It's really like an important step to keep in mind. Think out loud so you don't lose the audience. A lot of people like really write, they have good ideas for the LinkedIn post, but they kind of skip the mental process. Here's how I think about this, okay? There's someone reading this, and essentially I'm assuming the person doesn't really like know much. So I can make a statement. I have to actually guide them through the thought process, especially when it comes to something complicated as math, because most people are not really good at it, and most people also hate it. So I kind of have to say, okay, you can guess 1.4 trillion passwords per second. So how many possible passwords do we have? I have to kind of like, I'm going to put this here. So how many passwords do we have? Password is 8 characters long, and there are 102 possible characters. And I have to kind of think, because I don't really like to use like it's 8 characters long. Can I find like another word for characters? Because I don't want to use characters. One, we're using it as like the position. If we have 8 possible positions to fill in, we have 2 possible choices. Maybe I even like uppercase, lowercase, numbers, special characters. It's a little bit longer, but it might be easy. Uppercase, lowercase, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, plus special characters. That means there are, so we're going to include this for like some people want to do the math and I just like feel more comfortable. Most people, it doesn't really like matter like what this number is. There could be like, I don't know, it could be like this. Well, we don't care about this because like what we're trying to do here is we just want to try to intimidate people with this number, like how big it is. So people don't even grasp how big this number is, but it just looks really big. So that's kind of what we want to communicate. But we're not going to do that. There is a faster method, so we can kind of shorten this, but there is an even faster method. And now I'm going to, instead of saying how about, we're just going to say we use the word list and check if our password is on the list. So we can also kind of combine this in the sentence so that we try out each of the 82 billion leaked passwords from the ROC 2020 word list in 1.2 seconds and check if our password is on the list. And wouldn't you know, over 34,168 accounts with the word password. There are over 34,000 accounts to protect their account. That means, actually, so we can kind of like let people like finish this thought process. Boundary, on the other hand, is 100% unique. So an attacker would have to brute force all possible combinations. Yeah, I think this is a good start. Should take 33 minutes to crack. Okay, so instead of like, so how do you generate like a super secure forward password for yourself? 1, use physical dices, one of the EFF's wordless tool. Let's say for more convenience. And then we're going to have like, follow me for more cybersecurity content in your news feed. It's going to keep it small and short. We don't going to overload this with like hashtags. Just want to have like few over here. And then like, going to add some references. I think now it's time to do some checks. I've already done some basic checks with Grammarly that I'm using here. If you always see this popping up before, what is it complaining about? Before I explain, sometimes let me just for fun replace this. Let's first discuss the math of password cracking. Sometimes I will make some weird recommendation which sound more corporate sounding, but they don't necessarily flow really nicely. So what I'm going to do is I have another tool here which I've been using for writing. Is called Lex. This has some AI-based checks. So what we're going to do is we're going to do them one by one. First do a grammar check and see if it finds any other things that it might have missed. Oh yeah, double. Okay, defeat. Sound like missing characters. Shit, it didn't make any sense, so it's not 100% all the time. Then let's run another one, which is quite a lot. It's called the brevity check, which omits needless words, which can make the pause really, really short, and is oftentimes really good for flow. So in this case, we could say it takes 0.0 seconds. So we don't have to take every bit of advice. I'm just going to take some before I explain why this is more secure than the first one. I actually like to prefer, I don't really like wordiness. Let's discuss password cracking math. I have to think about if I want to do that. It takes 2 hours and 19 minutes, or about 2 hours and 19 minutes. But there is an even faster method. We try each of the 82 billion passwords on Rogue 2020 word list and to see if our password is, and what do you know? In case you're wondering, this is over 34,000 accounts use password to protect the account. So it's important, of course, as we don't do anything here because it's password. So what we can do is we can cut this out. It's 100% unique. So an attacker would have to brute force, taking 63 billion years, want to create a super secure password. Here's how you and EFF's word list to generate 4 unique words, or for more convenience. So I think this is kind of good. What kind of extra checks can we run? Let's do some more. I mean, I don't think there's that much extra that we need, but it's so fun. Let's run another one. I think it's actually not too bad. So this password takes 0.001 seconds. I mean, if we wanted to, we could do some math and but we don't have to overdo it. What we can do, it takes to break. So it's actually quite tricky. How about we use the help of some AI to see if we can find something like this? Give me a few ideas for a strong hook for this LinkedIn post. This is my working draft. Okay, that's totally useless. Stay closer to my idea. Just using GPT-4. So I think this is more like what I was looking for. So let's have a look. It takes 0.1 seconds to break this password, but 63.4 trillion. See, the trick is we want to kind of hide what it is. But it's kind of it's a good idea to start with can be hacked in 0.1 second, but this 4 keyword virtually unbreakable. I think this could be a good the difference between a weak password and uncrackable one might surprise you. This, on the other hand, it's a little bit more brainstorming. The math behind password security is mind-boggling. Password is easy to crack. You see, this is actually also not too bad. So let's copy this in over here. So this is something you want to spend a bit more time. So we're going to use this. Yeah, I think this could be a good one. And we can use the green check mark as a contrast. So this one could also be a nice hook. Think your password is secure. Think again. Password, 0.0 seconds to crack. Boundary code, combination defeat. We see that it's kind of a tricky thing. I'm not 100% sure which one will work. So I might edit this later once I published it to see. Sometimes it clicks, but you don't really know why. It's just fine. You just have to try it out. So think your password is secure. Think again. Password, 0.0 seconds to sync boundary call defeat. Here's why. Then we can actually skip this, which actually is kind of nice. I'll explain why this is more secure, why the second one is more secure. And we can kind of omit this. Let's discard password. Let's discard the math password cracking. See, some of this Grammarly likes to like reorder the words, but I want to kind of emphasize the math password cracking, not the password cracking math. Like this sounds like more, I want to highlight emotional trigger words. So math is definitely something that some people might not feel like, wow, I don't really like the math. So it's really like important to hit people with like those emotional trigger words to make the post more engaging. A high NPC, I think what we could say high NPC. Just some quick ideas how we could rewrite this. Could say high performance personal computer. That's not really helpful. Share like this one. This is kind of good. It's kind of like the reason why this is good. Let's actually put this in here. A single second is all it takes for a high-end PC to check 1.4. We actually have to double check that this is the number of characters. So we have like 1,000, we have 1,000,000, we have 400 billion and 1.4 trillion. Okay, that's fine. You could even like do some math. It's all it takes for a high-end PC to check 1.4 trillion unique password combinations. So we can actually like maybe omit this sentence even further. How many possible passwords are there? Let's actually use the logic. So it's kind of like easier. It has 8 characters. Actually, I don't really want to like do this. Let's keep it like short and sweet. It has 8 characters. Each character can have 102 possible values. Uppercase, lowercase, special characters. That's 11 possible combinations. And would take about 2 hours and 19. It would. I think what we have to do here is there is another one, like we improve the flow of 5 variations. I think this could be the one. So the reason why we want to have this flow in just 2 hours, 90 minutes, and Attacker could try all 11 possible combinations. There is an even faster method. It's less than a second. We use the database is a better word than I have a dictionary. That's like what more people can relate. We use the RockU 2021 data. And actually, we can reduce the RockU database with 82 billion unique passwords. We use the RockU database with 84 billion passwords. This only takes, we're just going to use it for consistency to take this out. So let's see if we can actually shorten this a little bit more. It's much better actually to use this feature. Okay, this is really not helpful. Let's try that again. I think something like this might work. So let's copy this here. I think this is the kind of post. And so all we need to do is kind of like take this entire, all we need is this entire post, and we can open up a new post, paste it. And then of course you see there's a lot of stuff missing. So we want to kind of like, now we're not going to have this much space. So we have to kind of like see what this can do. So I'm just going to add some line breaks that we previously had. Now, yes, I think we don't really want to have like anything attached to it other than like maybe like an image. So every time you hit the enter key, it will reattach like the first link it finds. So you always have to kind of click the X button to remove it. And then all we need to do is click the post button. And how is this post going to perform? Well, we're going to see. I'm going to send you out the link when I'm actually going to post it. I'm going to probably schedule this down here. And then like maybe you can leave me a nice comment under it and let me know what you learned about passwords. I'll see you in the next one. Bye.